or come back to it. So GTsummary tables. So one of the most common tasks for anybody working with data is to make tables, right? And tables in like producing nice tables from our results has always been a pain. Well, for me at least, like when you have to respect a certain formatting, especially if it has to be in Word, which is unfortunately often the case, it's a pain. And so what I did, so I'm talking about myself. So I tried to more and more code all the details of my table. So it was producing super long codes, which is in itself prone to error. And so I was using Cable Extra recently, which is an awesome package, but still you have to do a lot of coding to have like the exact formatting. And you always end up in Word having to do some formatting, like the lines and the spacing. And so it's not good. And it's always been like that. So, so GTsummary, I had heard of for a couple of years already, and I've seen people saying a lot of good about it, but I had this feel of it as being like a black box, which when we do R and programming, we instinctively don't like. And so, okay, I saw it in the background, and at some point, somebody convinced me to try it, and I saw a quick demo, and I said, okay, I'll try it. And actually, I really liked it, and I adopted it super quick because you can really feel it was developed by somebody from the field, like somebody who really uses it and does tables in real life. It's not the kind of package that's super like good in theory, where you can do a million stuff, but in practice, it's not easy. It's really like down to earth functions that you use and need, like most of the people who need to produce tables. So today I will use the slide. So the guy who developed the package is Daniel Stroberg. He allowed me to use his slides today because they are super cool and everything's in there. And so we thought of maybe doing it in French, but we'll do it in English because I know a bunch of people on the call, they don't speak English, so it'll be in English. So where, maybe I should have this, where this came from, why he started to, so he's a statistician. He does clinical trials, I think. And so he is really, since he was sensitized to the reproducibility crisis. So I won't do too much about this, but basically 10 or 20 years ago, people were starting to realize we're producing a bunch of results that nobody can reproduce. The code is lost or bad. The tables are from Excel, it's copy paste, and nobody can reproduce them. So a lot of things have been developed around that. We have a few talks on the topic already on the past years, which you can check out on the site. And making tables is an essential part of how you present your results. Okay. And so the GTsummary package was developed. So first it was like an internal package to their team, and then it was so good that they made it available, and it's growing super fast. So it's based on GT, hence the name GTsummary. So GT is the package developed by RStudio to make tables. So I don't know GT that much, but it's supposed to become the ggplot of tables. So that's my understanding. So it creates summary tables. So it's all the kind of tables that you will see in scientific articles or like scientific reports, like a descriptive of your population, cross-tabulation, regression model outputs, all kind of regressions, and building on that, you can do more complex tables. And also you can use all the results of your tables in text in a super easy way, which is really good for reproducibility. It means you can write literally an article in Markdown or Quarto or whatever that updates as your analysis updates. No copy pasting in Word, which is the nemesis. And so you can build, so it provides like basic building blocks on which you can use to make super complex tables. So I will only show you the two, I think, most useful functions. And I will quickly browse through the rest, but we'll just focus on the two main functions. So we'll be using a data set for this talk, which is a drug test data set. So basically you have treatment A, treatment B, and a tumor response. And the goal is to see if treatment A is better than treatment B for this tumor. So you have a treatment, which is the chemotherapy, age, grade, which is different level of tumor, and the response. So the main function is table summary. So this is the one that I think I use the most and most people use the most. So this is, we can see, right? How can I move this? So if you just apply the table summary function to our data set, this is what you get. So it's a super good start. It recognizes the type of the variable. It will give the most common way to describe it. For continuous, you will have median and IQR. For categorical, you have N and %. It gives you in the footnote all that's going on. So if it's presenting a median IQR, it says so, N %, it says so. For dichotomous variables, so it's binary variables, it recognizes several types of coding, which are common and which is very handy, yes or no, true or false, or 0 or 1. And it adds by default a line for the unknown. So it's like a really good way of describing your data. Oh, and very important, it uses labels. So it's worth spending time at the beginning of your analysis to label your data, because all your outputs will use the labels and will be super clean, like directly. So now if you want to customize your tables, you have a whole bunch of options. So this, I'm just showing all the basic options, but there are many more that you can figure out in the help. So you can stratify. So here he decides to stratify by type of drug. You can change the type of statistics. So for example, the default for a continuous is a mean and a median and IQR. So you can set here you can change it to mean and standard deviation, but you can use a whole bunch of stats using the glue syntax. I don't know if you're familiar with this, but basically you put function into brackets and it uses it combines text and functions. You can specify the labels within your call. You can change, so you can specify the number of digits you want output for like a specific variable. And so the way these functions, these arguments are written is using the function syntax. So you have the tilde with the tilde. So you have all the variables for which you want to apply a certain option, tilde, and the option. So, and so one other super handy thing is that it uses the tidy select functions. So if you want to apply a certain option to, let's say, all the variables that start with a certain prefix, you just do start with, you can do the detect, the ends with, it's all the tidy select functions. They're super handy. And if you want to do more than 2 different calls, you can use lists. So you can just input a list of all your different options and functions, and it will apply them. So I don't know, for those who haven't used it, if it looks complicated presented like this, but as soon as you start to use it, it's super intuitive. So this is for the basic table, the summary. And after, you have a whole bunch of add functions. So I will show a list, but to add elements to your table. So it's all common elements. So you can add p-values. You can add p-values corrected for multiple testing. You can add columns with number of observations. When you have stratifications, you have like n columns. So I'll show later. You can modify all the footnotes, the headers, the way the table looks. You can bold, italicize the rows, the labels, the titles. And so if we have a look at an example, it looks like this. So this was the table without the correction is on the left. And then you see you have this add p function here. And so you add like layer by layer. So you add here, he added a column for p-value. So using the type of variable, it knows the type of test you need to apply, and it's written here which test was applied. Q value, so this is p value adjusted for Bonferroni. So here I think it's Bonferroni, but it could be other, and you have a whole bunch of add functions to add to your table. And so if you check out the reference website, so I'll put all the links on the on our website later. You have a whole list of functions that are super handy for this kind of table. Okay, and you can check them out on the website here. So feel free to interrupt if you have questions. I didn't see. So here another example. So you can add the difference between two columns, which can be useful in this kind of situation. We are comparing two treatments. So this is what I was saying. You can add the ends, which is very useful. You can add an overall stat. So this is the descriptives per drug, and you have an overall in the same table. So these are super common things we do in tables, especially in papers, scientific papers. So this, you can add customized statistics, and there's a whole bunch of functions. If you don't find it pre-programmed, you can write it yourself. So these are the bold, italic. So you can bold the name of the variables, italic the levels. You can bold the significant. So here you use a threshold of 0.8 because it was all super high, but you can just highlight those that are below 0.05. Another super common thing to do. So these are for the adds, and basically you just add them one after the other using the pipe. So modify is the aspect of the table. So here you can modify the header, which is maybe looks nicer this way with a spanner over the two columns. You can modify the footnotes. So this is a table summary function. Any questions? No? And so for those who are here, what I'll do at the end, I will show a table that we need to replicate, and we'll try and do it together. And for those who are not there, we can see how it works out. So these coming functions, I won't spend too much time because they are wrappers around stuff that table summary can already do. So table cross, it's just a cross table with nice options with the percents and so on. Survey summary. So this is for survey data. So you can give weights. You can take into account weights in your statistic and so on. You can describe survival data also, which is very handy. Cumulative risks of mortality at given time points. And so the second super useful function is table regression. So this one, it takes the output of of a lot of our models, which are known to be not easy to manipulate and use, and it converts them in super nice tables, similarly customizable. And so behind the scenes, it's a heavy use of broom tidy. I don't know if you know this function. And it just goes a step further than broom tidy. Because broom tidy gives you like a tidy data structure for your model output, and this converts it into like a nice table. And so the only, so this is the model that was done in the coming examples. That's a basic logistic regression. So if you just by default enter the output of your regression into the table regression table, this is what it looks like. So super good features that are not even included in the Broom package are the reference level that are included for the reference category. You know what is the statistic. You have the 95% confidence interval for all models. And so, of course, you can customize the way you want it to be output, the p-value, and you have the footnotes. So you can add a bunch of additional statistics. So you can add the overall model summaries and the ends, the AIC, BAC. You can, so if you, of course, if you exponentiate, you don't have log odds anymore, but odds ratios, and all is explicit what's going on. So these are a non-exhaustive list of models that are supported, which is a lot. And basically, it's all the models that are supported by Bloom Tidy, from what I understand. Also, it does univariate analysis on whole data sets. So that is super handy if you want to be lazy. But I mean, you are being lazy, but it's you have control on what's going on. So you see the ends, the different ends for the different variables, of course, because you have different levels of missingness and so on. And this is usually useful in the first step to multivariate analysis. The inline texts, which is what I was saying, is when you can cite values from your tables in a text, in a paragraph. And so you can, so it uses the glue syntax again. So the default is to give you the estimate and the confidence interval, but you can parameterize it the way you want. And the way you use it, so you have your text here, so your markdown or your quarto, write it like this, so which is pretty short compared to what can be done and what I have done. and what you see in the report is this, which is, I think, nice. And so another really good feature is that you can combine all of these tables any way you want in a super easy fashion. So you can use table merge to merge them side by side. Right? So the example here is to merging the univariate and the multivariate tables. So the code is the same that we saw. So we see it's like not too extensive. And so these are the two separate tables. And if you merge them just with this code, you have this like super nice looking table with not too much work. And it's something like this that we'll try and do after. So stacking is to combine them vertically. So here is unadjusted and adjusted model. So you have the two A and B, and if you stack them vertically. So this is not so nice yet, but I know work is getting done to make it look a little nicer. Yeah, so this package is developing quick and currently, and there's a lot of contribution, and the guy is super reactive to answer. So it's getting better by the day. Strata is to further stratify your tables. Also can be handy. And so this is an example of a complex table just using the basic blocks that I showed you. So it uses, so you have table cross, a table, so several different tables that are combined using merge and stack and so on. So another really nice thing, so like ggplot, once your tables have been all produced with the GTsummary, you can apply a theme to them. And so this is the basic theme. It's according, I think, to the JAMA. So you can change language. So the one I use the most is this one, is to use a more compact version. And actually, so all you need to do is to cite the theme, and all the output will change automatically on all your tables. And so you can customize your themes also, make your own. And I think he is super happy to get people to contribute. I think that's one of the goals at the moment. So this is out of date. So I think I'll check the latest one if I have it. So this works really well when you export to HTML in your markdowns and quartos. And unfortunately, most often, we still need to export to Word. And this is a picture saying which kind of format works well with which output. So this means that before, before exporting, you need to convert your table summary, your GTsummary object into one of those formats using the following functions. And basically, GT works well with HTML and still in progress for the others. And from my experience, Flex table is the one that works like the best to export to Word. Okay. Oh, I forgot something. I have some data I need you to take for the second part. So you can take the data and pass the USB for. Okay. And I think we're close to done, and then we can start to play. No, that's it. So it's in my opinion, a really useful on a day-to-day basis package. Helps reduce the length of the code and the number of word manipulations and copy pastings and the usage. So this is I don't know up to when, but it's exploding. So a lot of people are taking it on, which is usually a sign that the package is solid and viable. So what I suggest now, do you have questions? What I suggest, I will show you a table, this one. And the goal is to try, so it uses the data from the USB key. That's okay. Is that working? Because if the data is not working, this is going to be complicated. So the goal, if the data works, is to, so it's a basic, so it's data that's from my work, but anonymized. It's people who have died from a disease, let's say. Yes or no. There is several continuous, so there's a continuous variable. The goal is to have several different types of variables. So there's age as category, so it's only in kids. Sex, we have 3 comorbidities, and we have temperature as continuous. And so this table shows you a description of the data on the left, stratified by mortality, so those who have died and those who have not, and a logistic regression, multivariate regression to predicting the risk factors of dying from that disease. So this is a super nice table, I think, that has a lot of information, and that's actually surprisingly easy to produce. The data, it's working or not? The CSV? Mais you were able to le récupérer, hein? Ouais, okay. And so for people online, I think this is where it stops for you. I prefer not to. It's anonymized. I mean, yeah, I could send it on the mailing list. No? How could I do it? What's the easiest? Yeah. Ça ne marche pas? Le CSV, il marche pas? Ouais, c'est vrai. Non, c'est vrai. No, I think so. No, it's easier, I think, if we stop here the Zoom. Do we agree? I apologize for those online. I hope it was interesting so far. J'ai le chat ou pas là? Non, j'ai rien le chat. Discussion. Yes, thank you. Thank you. So bye everyone, and see you. So when is the next one? I don't even know. November 11. See you November 11. ggplot, ggplot November 11, and Plotly and interactive plots. See you all. Bye bye. Ok, donc là.